Hi, my name is Connor Kutz, and together with Cole Weinhauer, we have created Aware. Aware is a pedestrian safety and awareness app. It's designed to eliminate the disconnect between headphone users and the outside world. We do this by providing alerts to the user through headphones in real time.
As we said before, we developed this app for pedestrian safety. In the most recent large-scale studies done of pedestrian accidents while wearing headphones, we learned two alarming statistics. One, that in just over 7 years, these types of deaths have tripled, going from 16 in 2004 all the way up to 47 in 2011. Secondly, you will see that nearly 70% of the accidents resulted in death. If both of these trends continue, then in just 2019 alone, we will see over 100 distracted pedestrian deaths. Thus, we can see why this technology is so important.
Now we'll take you through the main features of the app, starting with real-time crime alerts. Using Crime Alert APIs, local police Twitter accounts, and a network of users, we provide real-time updates in the event of nearby danger or criminal activity.
Next, we have our name recognition system. For the name recognition system, we ask the user to say their name when they first load up the app, and then we use Google Text-to-Speech services to get the name as text and save it on the app. After, we feed the microphone recordings into the same text-to-speech service, and if it returns with the user's name, we alert the user.
For crime density alerts, we gather crime data from the previous 30 days. Then we calculate densities and display this to users with a live map. Using location services, we can warn the user when walking into an area with higher than average crime density.
Next, we have our noise detection system. We designed our noise detection system to get real-time classifications on urban sounds. Our model was developed on Python using the Keras sequential model and achieved over 90% accuracy on an 80-20 training testing split. We then use TensorFlow to deploy the model to Android, and we feed the microphone data into it to get classifications of sounds. We then alert the user if the system hears any of the three following sounds: car honks, gunshots, and emergency sirens.
Using Cole's noise detection, we can classify sounds heard by the phone's microphone and send the data with locations to Firebase. Then we can alert any nearby users of possible danger. Most importantly, since there is no need for human input, this is much faster than GW alerts and other crime services. Our last feature is active volume management. This allows the app to compensate for the ambient noise level around the user. It functions as a convenience feature so they can always hear their media, but it also functions as a safety feature so the users can always hear our alerts. Here, we'll show you some examples of what real-world usage might look like. This first demonstration is what would happen if a user were to walk into an area of high crime density. As you can see, there's a lot of crime in the Georgetown area. If I adjust the phone's location to simulate walking there, an alert is sounded, warning the user.
Warning, crime density is higher than average near your area.
Our second demo is an example of an alert for a nearby crime update from an API or noise recognition. Any user within a predetermined radius will be warned like this.
Warning, a robbery was reported at the M Street CVS.
The final demo will show off the sound detection system using the sirens as an example. When we hear nothing from the mic, we don't get any alerts. But when we hear sirens,
Warning, sirens were detected.
now the user will still be alerted to the sirens even if they don't hear them. In conclusion, Aware is a pedestrian safety app that we believe will limit the number of accidents and deaths for users wearing headphones. It will do this through spreading crowdsourced crime alerts faster than any other service can, classifying urban sounds as they happen, and through crime hotspot identification. Thank you.